Okay, quickly, good afternoon, everyone. Again, we started from page 1, a new version of the book. And page 1, it says, in the past few years, artificial intelligence, or AI, has been a subject of intense media hype. Machine learning, deep learning, and AI come up in countless articles, often outside the technology-minded publications. We are promised a future intelligence. Intelligent chatbots, self-driven cars, and virtual assistant, a future sometimes painted in a grim light and other times as utopian, where human jobs will be scarce and most economic activity will be handled by robots and AI or AI agents. For a future or current practitioner of machine learning, it's important to be able to recognize the signal-to-noise ratio so that you can tell word-changing development from overhyped press released. And our future is at stake. And it's a future in which you have an active role to play. So we are going to decipher, we are going to discover everything in the book. The first question that I ask from our friends is to draw a graph and define a relationship between artificial intelligence, machine learning, and deep learning. I'm going to walk around and see what are the outcomes. Standard graph or just a simple, for instance, circle or something. I've searched it once how to hide this guy. Okay. One second. The quotidian relationship, and maybe just draw a graph you already have in front. Yeah. And the next question is, what would be the relationship between data science and artificial intelligence, machine learning, and deep learning? So the next question is, find a relationship between data science and AI, ML, and DL. Anyone who come up with the idea, please just raise your hand. Close, but not exactly. Yes. The first part is fine, but what is the data science? Not exactly. Okay. Because we have lots of things to cover. That's why I need to quickly go to the answer for this one. Most of you have already said the relationship between artificial intelligence, machine learning, and deep learning is something like that, right? So deep learning is a subsidiary of machine learning, and machine learning is a subsidiary of artificial intelligence. What is common between machine learning and deep learning? It's a silly question. The learning part, right? Both of these intelligence are based on learning. What is the definition of learning, if I may ask? Guys, yes. Acquiring knowledge. Acquiring knowledge. What is the difference between learning and storing knowledge? Yes, Dash.
Understanding what you're
Understanding.
Process it.
The problem of saying understanding is something quantitative, right? Something, sorry, qualitative, not quantitative. So we cannot say computers can understand or not, but they react based on the data that they receive. Right? For instance, the fan of your computer above a certain degree is going to start working. It doesn't understand that it is hot or not, but it does something based on the data that it receives. So in that case, yeah, computers can understand as well. But the question is, what is the meaning of learning? Learning means you do something, you find mistake, you correct yourself, and bring it to another level. So it's a combination of try and error. Does that make sense? It's exactly what happens in machine learning and deep learning. You do not start with amazing outputs. You start from low, you make it better and better. Does that make sense? Okay. So please draw a graph that shows relationship between machine learning, deep learning, AI, and data science. Whoever could finish it, please just raise your hand. Nash, your number is 89. Please just remember 89 in the first one spot. And 132, Zoe. You don't need to remember the last name. It's easy to find it. Yes. Excellent. Is there any concept that we have for deep learning, for data science, but we don't have for this part? Number 49. Those who received bonus, you don't need to stay after the class to check your lab mark, right? So including you. Yeah. Okay, please look at this one. This one shows the relationship between data science and deep learning, machine learning, and artificial intelligence. As you see, data science partially has relationship with deep learning, partially with machine learning, and partially with artificial intelligence. What I very much like about this graph is it shows that deep learning has relationship with big data, but not machine learning necessarily. And big data is something between these two guys. What is big data? A data which is big, huh? Is it correct to say a data which is big data? Yes. Do we have a data which is not big, but still it has the concept of big data? A bonus question. What are the features that makes a data set in the category of big data? What are the features? What are the characteristics? Yes.
It's very complex.
Who said volume? Okay, very complex. You know, when you say complex, how you can just define it? Okay, so how about searching? Okay.
Volume, velocity, and variety.
Volume, velocity, and variety, right? There are 3 V's. Do we have more V's? Yes. Please.
Variety and variety.
So he added value into the list. So 4 V's so far. Do we have more V's? Sorry? Variety already mentioned. So 4 V's so far. Just we have 4?
variability and veracity.
Veracity, reliability, what else? So now 5, yes. How about visualization? Is it part of big data? Okay, it's a good topic to search and research, guys. Whenever you get all the needed V's, then we are going to proceed. Yes. Yep.
So we have 7 components, so the 6 one is visualization, and then
Mhm.
also I think variability.
Nikita, your number is 87. For answering this question, what is big data? Very simple. Just type 7V big data. And then you're going to have something like this. Everyone, especially those who didn't participate to get bonus marks, please say, everyone take care of one of these V's and then get your bonus mark. You can just say, hey, I reserve 1, 2, 3, then people could just work on the others. Rostam, we work on any of them? Okay, it's not that difficult. First one, who's gonna be the winner of first bonus for this? Yep.
The first one is volume, right? So it defines how much data we have, and since
Mhm.
the data is like so big, instead of using just regular gigabytes, we can also use zettabytes or yottabytes.
So when the data is big.
Yeah.
Your name set?
Then
Start with N, right? Okay. Your number is 91. Velocity. James, you want to say? Please.
In terms of speed, how much data is processed?
The speed, well, the translation is exactly speed, means that, for instance, how fast they generate data for you.
Yeah.
The sensors that, yeah.
How fast it's available?
Sure. What was your number, sorry? Yes, 49. Variety, yes. Pardon me? Different types of data we have in SQL as well. We have in Oracle, Microsoft SQL, and so on. What is the difference between the variety of the data types that we have in SQL and in something like big data? Any idea? What is the difference between variety of data types that we have in something like SQL, Oracle, and in the concept of big data? Because if it is just the difference between text and numbers, we already have it in SQL. So what is this variety referring to? Yes,
Comes from different sources. And the diversity.
okay, exactly. Jason, right? 52. Look at this. Because, for instance, in something like an airplane, we have hundreds of thousands of sensors. One of them is made in China, the other one is made in India, the other one is made in USA, and they try to collaborate. And they generate different sort of data, right? And they are not necessarily compatible with each other. We have a huge, huge ocean of data. So that is variety. Different sources of data that they are not going to be necessarily compatible and fit into something like SQL type. What is variability? Anyone? Hey? So, yep. Variability. Number 4. If you like. I'm sorry, I cannot hear. Would you please just. Thank you. Yes, please. Okay. Cool.
Something that feels content, something that feels frequent.
Hmm.
Think like a variable, like if you define something that is changing again and again, and on order to like get some result, you need to consider that thing.
Number 99. Correct. How about veracity? The others first. Okay. Please, somebody who hasn't received any bonus mark specifically. Yes, Kumar. The accuracy. It's a little. Add 2 more flavors into it. It's not just only accuracy. Accuracy and reliability, right? And trustworthy. Okay. So, Mr. Kumar, your first name is Pavan P. Pavan Kumar. Yes. 97, your number. And Daniel. Can you please just, what is the first letter of your first name? Okay, don't worry. What is your first letter? It is not here. What's your last name? Okay, can you please just come here and search? The last one. Well, actually, let's talk first about value, then visualization. And visualization is not that simple. Value, what is the meaning of value? Yeah. That's volume.
Basically, what we're getting about, like, getting out of everything.
Okay,
You want to cancel the return on processing everything. We're getting out of it. Yeah, you just-
okay. Temporarily, I just put your name there. Nash, technically. It means that not all the data that we have in our data set are valuable. Not all the values that we have are valuable. Okay, that's about value. I teach this semester at one of the universities, course named database and database management and design. Yesterday we had a class and I asked people to design something like Uber. What are the things that we need to create a table? The person said membership number, awesome. First name, last name, yeah, phone number, address, correct, gender, was it? Why? Because this is Uber. Right? So we don't, when you don't need a data, don't include it in your form. And that's about value. And what is visualization? You might say, hey, it's just having graph. But you want to explain it as a part of big data to somebody who's not in this field. How are you gonna explain it? Anyone? Yes?
Something like an visualization from and showing the relationship between the one and another.
A data set that you have, imagine that has millions of rows. Huh? Can you bring that to your manager and say that, okay, see if you have any increment or any decrement? What is that? That's just a raw data. What's the first step that you're gonna do to change it, to make something out of it? Yeah, don't hesitate, say it. What is the first step that you're gonna do? Yes.
Validate the data.
Validate, it's part of the data engineering. After that, what are you gonna do? Some statistical analysis, adding some columns, calculating the average. What do we call that? Process, right? And process converts raw data into. That's not trick question. You have heard hundreds of times. First, we have data. The second phase after processing, we have. Yes,
Is it null?
information. Right? So first you have data, you do the process, over 1 million rows of data, then you make, for instance, 100 lines, and you call it information. But is it possible that you bring 100 lines to a meeting and show every line to the audience? So what are you gonna do? You're gonna use visualization to make information into knowledge. So guys, always remember and write that note somewhere. This is super important. We have data, we do the process, make information, and we visualize it to make knowledge. This person is John McCarty. He's one of the legends in the computer science. He envisioned some of the things that are happening nowadays, almost 60 years beforehand. One of them was cloud computing. In 1960s, he envisioned that you're going to have cloud services without saying that cloud services. Saying that you're going to use computer as a service one day, like the way that we use telephony and electricity. Okay? Just search about what are the 4 services that we use nowadays in our home. What are the 4 services that we have? What are the 4 services that we have in at homes today? Yes,
Electrical,
electrical, awesome.
gas, some
Gas, lovely.
water.
Water,
And internet.
But for the more correct. Any sort of. So electrical, gas, water.
Telecommunications.
Telephone, exactly. Now it's converted to telecommunication because necessarily we don't use old-fashioned phone. And the 5th one is using your computer, plug it into internet, wirelessly or through the cable, and use services hundreds of thousands of miles away. That's the concept of cloud computing. This gentleman envisioned that, but look at this paragraph. I'm going to just tell you the gist of it. And that is, he thought that we already have everything that we need to mimic, to simulate the structure of brain. And we can make something like human can decide for anything. We just need a couple of engineers, bunch of engineers, and just one summer. That's it, and we are going to have everything. Look at the next few lines. It says that at the end of the summer, the workshop concluded without having fully solved the targets that they aimed at the beginning. And still, we are not there yet. Many summers passed, many engineers gathered, and we just are at the beginning of the era that we think we can include AI in our daily life, right? We have other predictions. We're going to get to there. The first nice definition of AI could be this. AI can be described as the effort to automate intellectual tasks. This is important to say, normally performed by humans. Is it possible to ask computer does something that human is not capable of doing it? Stefan said no. Who else?
Sort of. I can't do half the stuff I ask it to do.
Is it possible to create something more intelligent than the creator? I'm not gonna go that road. Is it possible for a human to make more powerful in terms of intelligence? Absolutely, yes or absolutely no?
No, it was never no, I was just thinking about it.
Okay, just can you search a little bit? Is it possible to create something more intelligent? Is that us? Why not?
Like, even right now, we don't understand. What we typically see is how we have, it solves problems.
That's a very good point. I'm gonna talk about it. In some algorithms, we can understand, like binary decision tree. We can understand, but for something like AI, deep learning, it's not easy. It takes for years if you want to do it.
What about,
Good. Pardon?
what about just like the processing power of like AI? Like, humans can't process things as fast as.
As fast as, but still we are capable of some of this stuff, right? I'm not gonna answer that, but okay. Do you remember I said what are the differences between AI, machine learning, and deep learning? Here it says that as such, AI is a general field that encompasses machine learning and deep learning, but also included many more approaches that may not involve any learning. So AI is not necessarily equal to a form of learning. It could be just a hard-coded definition, instruction. Consider that until the 1980s, most AI textbooks didn't mention learning at all. And what is learning? Again, being physically in a class is not important. Being productive is more. So please do not idle our friend. Thank you. So look at this one. What is the process of learning? It says that one example, I received that question, Reza, can you give me an example of AI which didn't include learning? Yes. Like Deep Blue project, you have heard of it. The project that defeated Gary Kasparov in 1997. The mechanism that they used, just giving all the instructions, all the regulations, trying to predict what is the next move, and based on that, what would be my move, and let's just predict a few more, and give weights to better movements. You know what I'm saying? So it's not any intelligence, it's just regulations. Early chess programs, for instance, only involve hard-coded rules crafted by programmers and didn't qualify as machine learning. A few years later, it was in 2017, not a few years, a decade later, 2 decades. They made a program that played AlphaGo. At the beginning, it was very dumb. It took 4 days to play just a simple game. And after that, started beating basic players, finally beat the champion of the Go game. Because it corrected itself, just in a kind of the spiral way, getting better and better and better. In fact, for a very long time, most experts believe that human-level artificial intelligence could be achieved by having programs handcrafted a sufficiently large set of explicit rules. And this was dominant idea till mid-1980s. What we call that kind of approach is symbolic AI. Now we see a new word which is mentioned here, expert systems. What is expert system? This is another bonus, especially those who didn't participate. Please search for expert systems. What are the components of expert systems? And can you draw a graph, pie graph of expert systems? Yeah.
There's three links to the textbook in the resources. I understand that one has the highlights, but where it's things.
Okay, so if you see the prefix of the first one is 01, that's the most recent. And the second, and third, they start with the 02. They are the old version. The edited one has highlights. But this one actually, partially, I woke up 3 a.m., 3:30 today. I just compared those two books, try to bring the highlights. They have quite changed.
Yeah.
So you're gonna have this after I just finish all those things. Definitely before the midterm, you're gonna have that. Okay. Any idea? Expert system, the components of expert systems. You can ask ChatGPT too. Yes, James?
So computer program that uses AI technologies to simulate the judgment and behavior of a human or an organization that has expertise and experiences in a particular field.
So it means that what are the hardware components that we have? What are the components, hardware components that we could have in the system? Definitely computer as one part, but what are the other parts? Yes.
Here says it has consists of 4 components: a knowledge base.
Knowledge base. Just pause there.
Yeah.
What is knowledge base?
Knowledge base, I guess, the data. Differences.
It's a kind of database. Most of they use a data warehousing using RDBMSs. Okay, so we needed to have a sort of database, RDBMSs. What else? What is the second component?
The search or interface system.
The search. Okay. What about the third?
A knowledge acquisition system.
Okay.
And finally, the user interface or communication system.
Okay. If you want to say it in a very plain, simple definition, you could say the idea behind expert system could be we have a database saturated with all the data possible that we can use, and a system that actively make queries to search through the database, right? What is the reason that they couldn't get the best result out of it? And after that, they started, deprecated. Any idea why the project was not successful? In 1980s, they started, but in 1990s, at the beginning of 2000, almost there was no sign of expert systems. Why? Simply you can search what are the reasons that expert systems failed. Yeah,
Says they were difficult to update. They
difficult to update. What else?
They could not learn.
They could not learn. It was just a kind of query machine. Yeah, what else?
They were brittle, so they could make grotesque mistakes when giving unusual inputs.
Uh-huh. So they didn't know how to react when something strange happens. There should be in the database. Otherwise, I don't know what to do. But the major issue that caused them to deprecate it, to just not continue, was one fact. Very expensive and high maintenance systems. So that's why it didn't justify the amount of money that you invest in that project. I said that as, let me just show you. Look at this one, we call it technology hype. Something that started, that's the initial phase. It goes to the peak. People think that it's gonna solve all the problems. Then it's going to go fall down here, and then it's going to correct itself. Tries to just find its portion in the market, right? What are the examples that you can mention in technology that you have seen this hype? I received a few nice examples in the previous class, so I'm sure that if you think,
So you're asking what technology like today that did this?
yeah, we have tons of it, right?
Cryptocurrency?
Cryptocurrency. Right? Everybody started thinking that, if I bought that pizza, then I would, everybody has that. And if we didn't have that pizza, nobody's gonna go to it. Okay, what else? When we talk about absolutely right, we need to be specific which part of AI. For instance, expert system, we had that ups and downs, and here we call it winter. Till this moment, we experienced 3 winter in AI. One of them, the second one, belonged to expert systems. The other example, nowadays, everybody says Tesla. Everyone starts saying, yay, well, we are gonna sell our car and just get Tesla, and then, okay, what if in the middle of road, you finish your, are you going to just wave your hand and say that, okay, I need, oh, you can't just use a gallon to carry the gas, right? Or we went to that approach for what reason? For pollution, right? Air pollution. Now we have a new type of pollution. After a few years, what are you gonna do with the battery? You know what I'm saying? So at the beginning, it was very promising, but what else? Smartphones. As our friend said, cryptocurrency. Almost all the technologies at the beginning. ChatGPT, they start saying, okay, we are gonna just predict the future of markets using ChatGPT. Yeah. There's one fact. This will never happen, my word, to deep learning. It is possible that you see changes on the surface, but you're not gonna have this because deep learning moves slowly but steadily. Okay. We talked about symbolic and we talked about machine learning. What is machine learning? Do you know the analytical engine, the first shape of computer, 1830s, 1840s, by Charles Babbage? there was this one programmer back then, the name of that programmer was Lady Ada Lovelace. And we could call her the first computer developer. And that is why, to honor her attempts and her works, they call one of the most important languages Ada in the level of C. It was very much popular in 1980s. She said something. The analytical engine has no pretension whatever to originate anything. It can do whatever. We know how to order it to perform. Its province is to assist us in making available what we are already acquainted with. It means that it is not possible to expect this machine to generate something new for us. In a group of 2, 3 with your neighbors, think and see, is it possible? That's the question, the second problem I'm asking. Is it possible to generate something more intelligent than our brain? Based on this, please.
Would be able to differentiate that. Yeah. Nice. Saving context, that's like.
Okay, sorry to interrupt you. While you are discussing, can you please include your thought about these 3 questions? Could it ever be capable of any original thought? Could it learn from experiences? Could it show creativity? Is it possible that you say, okay, I want to have symphony number 10 from Beethoven based on the past 9 things? Is it possible? How about generating the next novel that never published by any author based on the previous way of thinking? Is it possible? Do you think that you're going to reach there? Sorry?
kind of creativity. What is it is among the possibilities. So what if we use something like brute force attack? Just try every kind of possibility. And if you think that I have the answer on this book, try to give you the final answer. Think twice. I just want you to think about it. The book is started with saying that, hey, you are as a hero, that there are false promises like creative chatbots. Now we use chatting just 2 years after publishing that. So it's good to think about them. And guess what? Amazing people in this field, they were college students and college instructors. So the sky is your limit.
Let's continue. This
is the GMC Sierra, powered by.
Yes. You know, the worst thing is whatever you search is going to, I mean, just show you that. Yeah, all the time, everywhere. Let me just tell you one thing. No, I didn't. I'm not a RAF person. I was just curious, honestly. Anyway, so look, what Lady Ada said was kind of questioned by a gentleman called Alan Turing. Have you ever heard his name? Sorry? Turing machine. What is Turing machine, by the way? Pardon me? Good, but lovely. That's what was this achievement, right? But what is Turing machine? It's a specific term, Turing machine. Can you please search? I've forgotten. What is Turing machine? Very simple. I remember I found something 30 seconds before.
Innovation doesn't happen on its own. It needs leaders to drive it.
Hi, welcome to another edition of Easy Theory. So we're ready to start new material now. So we've been talking about these things called DFAs.
Yeah, I think that I prefer to explain myself. The Turing machine is, anybody found the answer? Okay, imagine that in the next room we have one, I don't know, human or computer that communicates with me. The Turing machine, the Turing test is about to discover if that identity is a human or computer. That's the test. Has 3 different phases. There are lots of comments, but at the beginning it was a kind of revolutionary discovery, how to distinguish between human and computer. But this gentleman, Alan Turing, was a phenomena based on something that he did in Second World War. And partially we owe him. Maybe if he didn't do what he did, we couldn't be here. Apart from it, one tragic, who watched the movie? 1, 2, 3, 4. What is the most tragic part? Sorry? Can you please elaborate more?
He had like, during that time,
Yeah,
he was nothing serious.
sorry. He belonged to LGBT community, and unfortunately, that was very sad. After he passed away, 50 years after he passed away, the Queen just said sorry for what we did brutally to you. Yeah, because he was not the norm. Anyway, look at this.
We're not winning it. You speak a word of what I'm about to show you, you will be executed for high treason. It's beautiful. It's the greatest encryption device in history, and the Germans use it for all communications. Everyone thinks Enigma is unbreakable. Let me try, and we'll know for sure. Mr. Turing, do you know how many died because of it? I don't. 3. While we've been having this conversation. Gentlemen, meet Mr. Turing. We to work together then. I'm afraid these men will only slow me down. Popular at school, were you? I'm short on staff. We get more staff then. You have 6 minutes to complete the task. It's not impossible. No, it takes me 5 minutes and 34 seconds.
You said to do it in under 6. What is it that we're really doing?
We're going to break an unbreakable Nazi code and win the war.
Oh.
You know, to pull off this irascible genius routine, one actually has to be a genius.
I'm designing a machine that will allow us to break every message, every day, instantly.
You're going to need all the help you can get, and they are not going to help you if they do not like you.
Have you decrypted a single German message?
You will
Never understand the importance of what I am creating here.
Our patience has expired.
No!
If you fire Helen, well, then you'll have to fire me.
Me too.
And me.
Better bloody work.
Helen, you do not have to do this alone.
What are you doing? What's going on? Navy thinks that one of us is a Soviet spy. You've got more secrets than the best.
Very much recommend that if you have time, spare time, just watch it. And maybe you are very much interested in continue your journey in cybersecurity. And there's one thing, if somebody is interested in cybersecurity, just please be aware that cybersecurity will be partially very much depend on deep learning pretty soon. I've recently read some articles. You can't easily find any part without sign of artificial intelligence, specifically deep learning. Now it says that the usual way to make a computer do useful work is what? Hard-coded thing, right? To just say these are the instructions, just follow the rule and just give me the correct answer. A computer program to be followed, to run, to turn input data into appropriate answers means we have input, we have a black box in the middle programs, and then we receive output, right? What would be the shape of machine learning then? Please draw a simple graph, whatever you think, and just raise your hand. I'm going to check and your presence as well as your bonus mark. Please. A traditional way, input, black box, process, output. How about machine learning? Anyone? Okay, look at this one. It says this is exactly like what Lady Lovelace said, step-by-step instructions for the analytical engine to perform. But machine learning turns this around. The machine looks at the input data and the corresponding answers to figure out what the rules should be. In short, it is something like what you've seen here. So we have rules and data for the classical programming environments. We do the process, and then we are going to have the answer. Like what? A is equal to 1, B is equal to 2. Those are the data points. The rule is summation, for example. You add them together, and you're going to have 3 as the answer. But how about machine learning? In machine learning, you say the data is 1 and 2. The answer is 3. What could be the regulation? And we're not going to just check it for one sample. We go through hundreds or thousands or millions of samples, making sure that our regulation works pretty fine. The question is, why should we bother when you have data and when you have the answer? What is the motivation for finding the regulation? There are 2 reasons. One of them is already said by Mr. Kumar. What's the number? 97. 97. Yes. Who else? Again, I'm going to repeat it. One is to predict the future. What else? Because you want to have a data and see what would happen next. Anyone? It's not that difficult.
Find the relation.
Understanding
The pattern.
the current status. Why the result is this for the current moment. Mostly we use a statistical analysis to understand the current moment, but we can use machine learning for that too. Rarely we use a statistical analysis to predict the future. Mostly we use machine learning for that. Does that make sense? The next part. Look at this paragraph and another bonus question. Hopefully some people could get it. It says, although machine learning only started to flourish in the 1990s, it has quickly become the most popular and the most successful subfield of AI. A trend driven by the availability of faster hardware and larger data sets. It means that we have 3 factors. I didn't mention the third one. 3 factors helped us to see machine learning. Exactly the same factors helped us to see deep learning. The idea of deep learning is something like 70 years old, but we have it just for 10 years. Why? What are the 3 factors? made machine learning and deep learning available. Please tell. Already you can see two of them here.
I found a computer less expensive computer and the third one. The processing time of
They are all about argument. The second one is already there too. Read the paragraph, please, again. Yes.
The development of more advanced algorithms.
Exactly. Can you please read the whole? I mean, say number one, number two, number three to everybody. Okay,
Oh, the whole, oh.
1, 2, 3.
Trying to provide the availability of fast hardware, larger data sets, and development.
Excellent, lovely. As Stefan said, there are three factors: faster hardware, larger data sets, and for sure, the algorithms, the development of the algorithms that we have in hand today. Okay. My apologies, we already passed a lot from the break time. So how about this? Let's have 10 minutes break. It's now 1:23. We're gonna come back at 1:33 and we continue our journey. Okay, thank you.
How it is, yeah, more like it. It's like kind of hard to keep. I mean, like, yeah, like, it's like, sometimes I don't think it's just like, why, yeah. Sure. Yeah, that's like, I'm saying, I'm like, this.
बहुत दिन नहीं बैठा कुछ नहीं बता रहे
Just each other.
He has another instructor. I have. This is there. I'll say, well, it doesn't make any sense. I'm doing this program that way, but. Yes, yeah. Yeah, it's fine. I'll be done, though. I could go. I'm starting to just buy something. Oh, and.
Okay, so let's continue. The question here is learning representation from data. In deep learning, machine learning, we have three phases. First, considering the input data. Second, examples of the expected output. And the third part is finding the distance between what we predict and what could be. Yeah. Okay. How can you calculate that? Look at this one. It says we need three things in deep learning, machine learning. First, input data. Second, examples of the expected output. And third one, evaluating our algorithm. What does it mean? A way to measure whether the algorithm is doing a good job or not. Can anybody come up with any example? Yeah.
Finding the accuracy.
Example of that. What is the accuracy?
Basically, you are having a prediction data and the actual result and compare both of them and getting the accuracy of it, like how much accurate is it?
Okay. Thank you. How about this? Imagine that you have 100 pictures of cats and dogs. 100. And you're going to predict 95 correct labels based on your algorithm. Right? So imagine that's 50-50. You just have 3 errors for dogs, 2 for cats. What is the accuracy? 95%. This is for one algorithm, like algorithm A. For the other algorithm, imagine that you apply that on the same data set and you're gonna predict 87 correct labels. Does that make sense? And then you're gonna say, hey, which algorithm is the best for this problem statement? I want to address one thing. This is our job as data engineers, data scientists, to pick a proper algorithm. And there is no one size fits all. What we normally do, we apply different algorithms in Python and see which one is going to give us a better precision or accuracy. Is it possible to use any other language? Yes, no? More specific, for instance, something like C#. Do we have any library in C# that helps us for machine learning, deep learning?
I don't know how to say it, that's K.
Scikit-learn? In C#?
Oh, not C#, sorry.
Okay, so would you please just search for it? Is C# capable of helping us in machine learning or deep learning? That's one of them. ML.NET. Okay, what else? Yes, sir. Both. have this capability. Okay. In one college, they asked me to teach advanced C#, advanced programming. And for the first time, I had to learn something. I was like, do we have any machine learning in C#? And then I started learning because I needed to teach it. And surprisingly enough, the intelligent part is it is going to select a range of algorithms like 2025 based on the nature of the data set that we provide. And among them, it's going to go through every one of them and gives you the benchmark saying that this is the best algorithm that gives you the highest accuracy. That's awesome. So, and based on some articles that I read, even the performance is double the Python. The thing is, it mentioned the measurement is used as a feedback signal to adjust the way the algorithm works. So learning is like good dog, bad dog. It tries to learn based on the feedback signal that you provide. And said, this adjustment step is what we call learning. Guys, very simple. Machine learning, deep learning, they're like life. You make mistake and then you learn based on the feedback that you receive. It says that a machine learning model transforms its input data into meaningful output, a process that is called learning, right? From exposure to known example of the input and outputs. We have something here that mentioned representation. What is representation? Yes, I know that we have a definition here. It says that at its core, it's a difference. It's a different way to look at data, to represent or encode data. But what actually it means? Can anybody decipher this complex sentence? What's the meaning of representation? So that's one representation. For instance, we have a picture and we convert it to series of zeros and ones. Huh? That's one thing. Awesome. Rachel, right? Your number is 104. Just please remember. Okay. Who else? If you see a color like red, what could be one system to represent that color? One possibility is using RGB, isn't it? This is one standard, red, green, blue. And the other standard is, as you know, HSV. If you are searching for the color code, the best representation would be what? RGB, right? But if you are searching for the hue or the saturation of a color, then the second standard, HSV, works the best. Does that make sense? So really it depends on the usage. You're gonna pick a proper representation. Now, one example, imagine that we have some black and some white circles. What could be the best representation that helps us to discover if a newcomer spot happen to appear on the image? You can say if it is white or black. What could be the best approach? Okay, and your row, if you have time, please work on this too. Okay, so what are the solutions, guys? Actually, in one of the sections, one student said totally wrong answer, which help us to see some algorithms, they cannot work productively. He said, okay, linear, I'm gonna use linear regression. Guys, what is the role of linear regression by any chance? To find a line which is going to map all the dots, right? Technically, you are not gonna distinguish. They're gonna make something in the middle. It's not gonna help. It's gonna map all the dots into one line, right? That's awful for that. So it shows that not all the algorithms are fine. Not all transformations are fine. So I'm gonna just come up with one idea. How about defining one line like this? It could be one, right? Just think about another solution. Yes. Bruno, you want to say something? You said, oh, just bad time for a stretching. Okay, who else?
Be able to categorize them.
Yeah, look at this one, the transformation. One is like this. We just transform the x's, right? It's gonna be y and x and y. This is one way, but a better one is transforming the dots. Means any circle, any dot that comes to the system, we are gonna transform it, and then easily you can say if the x of that dot is less than 0, then it is white, else it is black. Does that make sense? So we have different possible representation. We need to pick the one that works the best for us. Please write one short sentence that summarizes learning. I've already made a kind of rectangle around it, but just paraphrase it the way that you can understand it the best. Look at the last sentence. It says, learning in the context of machine learning describes an automatic search process for better representations. That is the major difference between machine learning and deep learning. In machine learning, algorithms, they have limited room to just play around with. We call it hypothesis space. It's like picking one algorithm. It's like going to Walmart, going to Canadian Tire, and pick one specific screwdriver or plier. Just pick limited number of tools. Machine learning is like picking a tool. Deep learning is like creating a specific tool. Write it somewhere, these two sentences. Machine learning is like picking a tool, while deep learning is like creating a tool. With knowing that, now read the last sentence. It says machine learning algorithms aren't usually creative in finding these transformations. So you need to have ideas. They are merely searching through a predefined set of operations called hypothesis space. So hypothesis space means that I go to Canadian Tire, just aisle number 11. I'm gonna pick that specific tool. Limited number of options. Searching for useful representation of some input data within a predefined space of possibilities using guidance from a feedback signal. What does it mean? It means you pick one tool, you see that you cannot fix the issue that much, the accuracy is low, then you're going to change it and pick another tool. So you switch the algorithms to get the better performance. Look at this one, deep learning. Deep learning is a specific subfield of machine learning, and you take on learning representations from data that puts an emphasis on learning successive layers. So it doesn't mean that deep learning is contemplating, pondering, deeply looking at all, right? Something like that. Deep addresses the number of layers that we have. In contrast to deep learning, we have shallow learning. So we could say machine learning are mostly shallow learning. Look at this one. It says that in deep learning isn't a reference to any kind of deeper understanding achieved by the approach. Rather, it stands for this idea of successive layers of representation. How many layers contribute to a model of data? 10, then you're going to say 10 hidden layers, then you're going to say the depth of that algorithm is 10. So how many layers contributed to a model of the data is called the depth of the model. Does that make sense? The number of hidden layers that we have. It says that modern deep learning often involves in tens or hundreds. In this book, we normally use 2 to 4 hidden layers. I already mentioned, compared to deep learning concept, the other algorithms in machine learning, especially artificial neural nets with just one hidden layer, we call them shallow learning. Yes.
When it says that, what is it mean to actually, like, is it the source of the data that we're
Getting it from, for example, it's an apple. So if you want to go into its hidden layers, would it mean the seed, where you get the seed, the soil, include on all that, or how will it be defined?
Okay, very good question. Look at this one. How many layers do we have here? 4. The depth is 4.
How is it defined? Like, what are those layers? The way we represent data, or I'm really confused.
Don't worry. We have one 12 minutes video that we are going to watch today. And hopefully we are going to get, but the first layer is the input. The middle layers are hidden layers, and the last one is the output.
Last week we worked with one of the tools online with just experimenting and playing with it with an paper where we were adding layers and checking the information like the output. But even then I couldn't completely understand what these hidden layers are like. Are they, for example, let's say x plus y, and then we say x minus y, and then x star y. Is that what the hidden layers are? Or?
I'm going to explain it thoroughly. Don't worry. Just stay tuned. Just know that this one, how many layers do we have here? Awesome. 3. What is this one? Input. What is this one? What is this? Lovely. Done. Here we have how many? 5. But the question is, you remember yesterday we talked about something like, imagine that I have a handwritten digits. Let's circle. 28 by 28. And I write something like this. Huh? Look at this part. In the extreme case, when we have nothing, we call 0. If we have anything, we are going to call that. So it's going to be 0, 0, 0, 28 zeros for here, 28 zeros for here, right? And how about this, guys? This is an important question that Alan asked. How about this? I'm saying extreme form. It's going to be 0, 0, 0, 0. And what about this one? What about this cell? It's going to be 1. Then again, 0, 0, all the way. But the problem is, the sensors that we have here are just one column. It's not like a scanner that you can just insert the paper and start just scanning it. So this one doesn't work, right? How can we change it? Look at this one. This is going to come here. This is going to continue. This is going to be, and this is that one that we discovered, and so on and so forth. You are gonna fit this one. What is the multiplication of 28 by 28? 784. And that 784 is the number of pixels that we have as the input. Does that make sense? In the extreme form, simplified version, I said that we have some zeros and ones. But the reality is the real data set contains numbers between 0 to 255. And the bad news is deep learning is not very comfortable working with big numbers. This is big for. So what should we do? Guys, is it easy to understand how we convert that part into that 28 by 28 into one column? We call this one normalizing. Oh, sorry, flattening. I'm sorry, flattening. Wanted to tell normalizing after that. The other name that we have for it is reshaping. Some references they say reshaping, some address it as flattening. And actually we have the specific function that we use flatten and does that. The other thing is, guys, what is the solution if you want to convert this range into something between 0 to 1? Very simple, we divide all the elements by 255, right? So the range would be between 0 to 1, and we call this normalizing. Did I answer your question so far? So the picture that we have, you're gonna just first make it one column. Flattening, reshaping. And then we do that calculations, like divide them all by 255. No matter if it is between 0 to 255, you're gonna divide it by that. Else, you're gonna divide it by the maximum number to make the range between 0 to 1. And then you're gonna define some layers. Question, is there any specific number for the number of layers? Is there any specific number for the number of neurons that you have in each layer? We call these things either activation or neurons. Right? I wish, there's one thing, I wish really you had a chance to read the book by yourself and see if it is understandable or not. Anyway. Any answer? Is there any specific number for number of layers, number of neurons? Is there any specific number for number of layers and number of neurons? Okay, I'm not gonna give the answer. Search. Hopefully you're gonna see in the midterm. Go to the next part. We talked about this neural network. Let's see the history. Yeah. Do you think that deep learning borrowed the concept from brain? Yes or no? Jason says?
Yeah.
Yes. Who else? Yes. Everyone? Repeating the question. Did deep learning borrow the concept from brain? Okay, let's see what neuron is.
Here in New Zealand, the sun is shining, but it doesn't just brighten your mood. It helps you.
I promise I didn't check anything about.
Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the neuron. This is a brain. Estimates vary, but right now the best guess seems to be that our brains contain around 85 billion neurons. The neuron is a nerve cell, and it's the primary functional unit of the nervous system. This is a generic image of a neuron. Neurons actually come in all shapes and sizes, but this is the prototypical version of a neuron that you'll often see in a textbook.
Okay, do you see any similarities so far between neurons and brain? Any similarities? Just we have this guy, which is called neurons. Let's see the rest.
The structures extending from the left side of the neuron that look a little bit like tree branches are called dendrites. Dendrites are the area where neurons receive most of their information. There are receptors on dendrites that are designed to pick up signals from other neurons that come in the form of chemicals called neurotransmitters. Those signals picked up by dendrites cause electrical changes in a neuron that are interpreted in an area called the soma, or the cell body. The soma contains the nucleus, which contains the DNA or genetic material of the cell. The soma takes all the information from the dendrites and puts it together in an area called the axon hillock. If the signal coming from the dendrites is strong enough, then a signal is sent to the next part of the neuron, which is called the axon. At this point, the signal is called an action potential.
Okay, this is the axon. Maybe some people think that these are like the layers that we have in. But the thing is, the process in here is going to accelerate the flow. But that is the most cumbersome process in deep learning, which takes the most amount of time. No similarities at all in here. Anyway, you got this one, and I want you all read this paragraph and then answer the question again. It says that deep learning models are not models of the brain, but it didn't mention it only that. Any volunteer to read this paragraph aloud for everybody? Voluntold. Nash, can you please? If you don't mind, please.
There's no evidence that the brain, anything like the brain, make up a cross sign or created a deep learning works like the brain or model that the brain. That is, you could be using it counterproductive. Newcomers feel think that deep learning is being in any way related to your bio. Don't need that trial because like our minds just keep this. And you may as well forget anything that you have read about hypothetical links. We keep learning about. For our purposes, deep learning is mathematical framework for the representation of data.
Lovely, thank you very much, Nash. Not a bad idea. Read it once again, just in one sentence. Write it for yourself and answer this question again. Did deep learning borrow the concept from the brain? Is this the model of brain? You have the answer in front of you, right? And surprisingly enough, in one video that we are gonna watch in a few seconds, it says opposite. I'm of the opinion that this one is true. Because actually I studied both. Except the neuron part, there is no other similarities. Okay. Again, come on. We have a handwritten digit. We bring it to the first layer. And you say that how that layer impact on the data. That's the question, right? And we bring it to the next layer, the next layer, the next layer, hoping that it's gonna identify number 4, right? Turn on the light in here saying that this is 4. What is this picture? What is this? A digit. Totally different. I have mentioned this link here. There we go. What is this? Anybody is familiar with this? Sorry? Yes, exactly. Distillation. It's going to, just purify, make it purer, 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 like layer by layer. It's exactly what is happening in deep learning. Look what it said. It's like multi-stage information distillation operation. It tries to purify, increasingly purify. Look at this example. So this is going to be 4 like this, 1 layer. It's like a sieve. Next layer, and so on and so forth. By saying that, we are ready to, this is the last activity of today's class, but I'm gonna pause and talk about some part of it. Unfortunately, they didn't fix
Last
the
video, I laid out the structure of a neural network. I'll give a quick recap here, just so that it's fresh. Last video, I laid out the structure of a neural network.
Yes.
This is a 3.
Sorry, the IT guys, they couldn't fix the problem of the speakers. So the subtitle is on. If you cannot hear it clearly, you can just, you may go in front of the class. Sorry about it.
It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea, while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this, and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly need to motivate the relevance and importance of machine learning and neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing, not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivated, and to feel like you know what it means when you read or you hear about a neural network, quote unquote, learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the 2 videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many, many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants. But in these 2 introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network.
Guys, look at this one again.
784 neurons make up the first layer of our network.
Isn't it beautiful? So we got it how it's shaped, just that 784.
Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit.
We need a specific function to tell, okay, the chance of being 9 is 0.97, right? So the audience do not like to hear, okay, the chance of being 9 is 97. I just want to pick one number, right? So we are gonna learn that, what are the, and we call them activation functions. What are the activation functions that we use for every single layer? That is going to just turn on this light without saying that, okay, the precision is this. At the end, you have to pick one number. This is the handwritten digits. They're gonna say, I think it is 9.
There's also a couple layers in between called the hidden layers, which for the time being should just be a giant question mark for
Okay, just wait a second here. We have input, we have output, we have hidden layers, we call either activation or neurons. There are lots of names. You're gonna get used to them. But what are these edges that connected all these neurons together? What are they? Cannot hear. Anyone? Okay, we call them, one of the names is parameters. The other name, the correct one, weight. And is this the only parameter that we have in deep learning? Please search. We have hyperparameters, we have parameters. What are the parameters in deep learning? What are they? Weights and? Anybody else? What was your number? Okay. We call them weights and biases. What is the role of any weight? What is the role of biases? What are the roles of biases?
The importance of the data, the way, how much data is being sent to the next layer.
Just have that question, and we are gonna get to that in a few minutes. Let's just see.
wonder this process of recognizing digits is going to be handled. In this network, I chose 2 hidden layers, each one with 16 neurons. And admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment. And 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with a specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now, the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these subcomponents.
Guys, this is very abstract way of saying it, but look, imagine that we only have this circle and this one. I repeated the first one and the third one. Which number do you think should be triggered? What could be the output? Yes. Excellent. Imagine that you have the first and the second one. Which number could it be? 8. You got it. So now, I'm not saying that now it should be clear completely. Is it clearer? That's the aim of this session. So we come from the totally pixels, the most left. We try to make it purer and purer, very abstract, close to what we expect as the output digits. When you're dealing with machine learning, you need to take care of the input very much. Data engineering is essential. How about in deep learning? In deep learning, because of these weights and biases, if the data is not important, it's going to cancel that road. It's going to take down the value of those connections, those weights, right? And finally, you're gonna see some of them are already turned off, some of them are active, give you the result that you expect.
There's some specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits. Of course, that just kicks the problem down the road, because how would you recognize these subcomponents or even learn what the right subcomponents should be? And I still haven't even talked about how one layer influences the next, but run with me on this one for a moment. Recognizing a loop can also break down into subproblems. One reasonable way to do this would be to first recognize the various little edges that make it up. Similarly, a long line, like the kind you might see in the digits 1 or 4 or 7, well, that's really just a long edge, or maybe you think of it as a certain pattern of several smaller edges. So maybe our hope is that each neuron in the second layer of the network corresponds with the various relevant little edges. Maybe when an image like this one comes in, it lights up all of the neurons associated with around 8 to 10 specific little edges, which in turn lights up the neurons associated with the upper loop and a long vertical line, and those light up the neuron associated with the 9. Whether or not this is what our final network actually does is another question, one that I'll come back to once we see how to train the network. But this is a hope that we might have, a sort of goal with the layered structure like this. Moreover, you can imagine how being able to...
So getting back to this picture, we understood that we have some weights and some biases, right? The result of applying those weights and biases on activations, what are the activations? These neurons, we call them activations. The result would be just saying if the number is 9 at the end, or 4 or 1 or what. Question, what are the initial values for those weights and biases? Are we calculating them? Does the system use some statistical analysis to come up with some values? Are they random numbers? I'm talking about the beginning. What is your answer? What are the values for weights and biases? Meanwhile, that you are searching for, the question is, what are the initial values for weights and biases? Are they based on calculations, statistical analysis, history, or what?
What's your number? Let's say 112. You think that was your number? Oh. Please show me. Sixteen. And numbers. Yeah. Yeah, there's. So. Replace. And then find there. I would say. Seventeen. Yeah.
I think the like motivation.
First, you know, you're on.
Is 1.7.
One, 17. One, 17, yeah, plus. Yeah. Sure. And your number. 50.
Okay, awesome. Okay, what could be the source of initial values? A statistical analysis, calculations, or what? Any idea? Bruno? You have any idea? Again, guys, should I just answer the question or you're gonna just try? What is the source of initial values for weights and biases? Yes?
Initialize with 0. What's the initial?
So one answer is initialized with 0. I don't know. Okay, if it is going to be 0, then all the time it's going to just point to one number, right? Oh, yes.
Biases are 0 and weights are.
What is the source? What is the role of biases? Yes.
To add characteristics to the weight to the value of the information.
Okay, yeah, biases are gonna just lift up the number or bring it down. Biases are on top of each column. So imagine that this positive 10 means lift them up, right? If it is -5, suppress them 5 units, right? To the whole column. How about the weights? They're gonna initialize, as one friend said, random numbers, say, right? Number.
Well,
1, 2, bravo. Okay, so deep learning, there's another methodology, recent one, but forget about that. I'm talking about deep learning. The initial values would be based on random numbers, and it's going to correct itself. Next week, we're going to learn how it's going to correct itself, and next week, we're going to start our hands-on. Suggestion, every week we cover something like 10 to 15 pages. Not a bad idea to read it in advance, to start trying it using Colab. So it's gonna help you to grab the course. It's not an easy course at all. I try my best, but it's not easy. It's totally different from the mindset that we develop in 3 years for programming. Okay.
Goal with the layered structure like this. Moreover, you can imagine how being able to detect edges and patterns like this would be really useful for other image recognition tasks. And even beyond image recognition.
This that you see here
would be really useful.
This is part of assignment number 3, if I'm not mistaken. We are gonna apply it. We are gonna make that. It's pretty close to what you do when you want to apply a filter on Instagram or something. We're gonna learn how to apply those filters.
For other image recognition.
What can you infer from this one? Which lines are more vivid, more visible? Like horizontal lines and some diagonals, right? Why we use those filters? Imagine that you have these filters and the number that you want to pass is this one. What could be the result of next layer? Almost nothing. What if you have something like this, 7 or 1? What is the output of next layer? It's going to be this. Do you realize how we are going to use these filters to just purify our data? Okay.
Tasks. And even beyond image recognition, there are all sorts of intelligent things you might want to do that break down into layers of abstraction. Parsing speech, for example, involves taking raw audio and picking out distinct sounds, which combine to make certain syllables, which combine to form words, which combine to make up phrases and more abstract thoughts, etc. But getting back to how any of this actually works, picture yourself right now designing how exactly the activations in one layer might determine the activations in the next. The goal is to have some mechanism that could conceivably combine pixels into edges, or edges into patterns, or patterns into digits. And to zoom in on one very specific example, let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things? Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use green pixels to indicate positive weights and red pixels to indicate negative weights, where the brightness of that pixel is some loose depiction of the weight's value. Now, if we made the weights associated with almost all of the pixels 0, except for some positive weights in this region that we care about, then taking the weighted sum of all the pixel values really just amounts to adding up the values of the pixel just in the region that we care about. And if you really wanted to pick up on whether there's an edge here, what you might do is have some negative weights associated with the surrounding pixels. Then the sum is largest when those middle pixels are bright, but the surrounding pixels are darker. When you compute a weighted sum like this, you might come out with any number. But for this network, what we want is for activations to be some value between 0 and 1. So a common thing to do is to pump this weighted sum into some function that squishes the real number line into the range.
There are two last things that I'm gonna tell you, and we're gonna call it today. One thing is, you see the numbers we try to, let me just squeeze it into something between 0 to 1. I already told you, deep learning is happy to work with the small numbers between the range of 0 and 1. And the other thing is, most of the things that we have in deep learning is based on empirical practices, not based on mathematical or statistical analysis. I remember the time that I was auditing one course relevant to data science. And the prof told us that year that the activation function that we used is something that they call it sigma. A year after that, the same prof, I audited the course again because that was, I'm telling you, it's not an easy course. So the prof said we use something that we call it revenue. Totally different. I was like, okay, last year you used sigmoid, why you changed it to revenue? I don't know. A Russian guy woke up one day in the morning, just used this function, and the result was better. So they started using this. Is there any reason, I mean, proof in math? Who cares? It just works better. That's it. And the reason that I mentioned that is, guys, I remember when, for the first time, I could get artificial intelligence. It was the time I was 22. I just refused. I was like, the prof is very much tough. I don't want to get that course. I don't care about artificial intelligence. Guess what? Now I just teach artificial intelligence in deep learning. And the thing is, if you want to just have a little bit of motives for this, those who followed what I teach in the class, they could get a job. At least I know one of them got 6 digits for the salary. The other one recently, I can just show you the recommendation that I provided for that person. I just tell you the first name, Mohsen. Mohsen got the job with 80 something. I'm not gonna tell, maybe you know that person. 80 some K first year. The only motives that you can just have with yourself is knowing that this topic is not easy, and read it by yourself before coming to the class, and you see that, oh, it is not something that I can learn it by myself. Honestly, I spent good amount. I spent very good amount of time, and I provided, if you see, and every session that before coming to the class, I work on the material. Look at the videos that I have provided, and I just thought that, no, I'm not gonna say these things today. I'm gonna just change. And even if you see the, let me just show you. Guys, do you see this? What is the date for the update for this file? 6/11 what? Which day? I woke up 3:30. I started continued working on that. I tried my best, but well, it takes two to tango. I'm not the only person. We need the other side to just say, yes, I want to get the best result out of it. Yes, I want to have data science not as my major maybe, but as a part that I can leverage and get the best job possible, right? So guys, this is just week number 1, and everything is already recorded. Okay, let's have, with that intention, let's just, have an amazing semester together. Thank you very much. See you next semester and next week. Sorry.